Introduction to tea fermentation in CTC factories. Fermentation is a critical step in black tea production. Involves passing dhool through a rotating drum with conditioned air. Duration 60 to 90 minutes. Oxidation of polyphenols enhances color and flavor. Oxygen and temperature control are essential. Dynamic process ensures even exposure to air. Blacker and brisker teas produced. Bulk density of tea increases. Precise control over fermentation parameters is crucial. Significant impact on flavor profile. The role of the fermentation drum in tea processing. Cylindrical machine used for fermentation. Conical feeding and discharge at both ends. Standard drum dimensions. 5 feet diameter, 16 to 20 feet length. Spiral flights inside lift and shower tea for aeration. Constant rotation ensures even exposure to air. Rubbing spreads juices across tea particles. Proper oxygenation, critical for biochemical reactions. Increases bulk density, desirable for CTC tea. Used in batch operations for consistency. Facilitates uniform oxidation process. Importance of oxygen in the tea fermentation process. Essential for oxidation of polyphenols. Mass transfer of oxygen, critical in equipment design. Enzymatic reactions depend on oxygen supply. Co-current airflow ensures optimal oxygen levels. Recycling spent air is not advisable. Fresh, cool, moisture-saturated air recommended. Proper airflow prevents oxygen limitation. Insufficient oxygen leads to uneven tea quality. Directly affects fermentation rate and efficiency. Oxygen helps produce bright infusions and rich flavor. Optimal conditions for fermentation: temperature, humidity, and load. Ideal temperature 25 degrees Celsius to 27 degrees Celsius. Relative humidity around 95%. Optimal drum load 550 to 600 kilograms. 20-foot drum 700 to 800 kilograms. 24-foot drum. Underloading results in less dense teas. Overloading causes uneven fermentation. Humidity control is essential for moisture retention. Temperature affects reaction speed during fermentation. Optimal conditions prevent issues like uneven flavor. Loading affects aeration and oxygen availability. Maintaining the right balance ensures quality. Batch versus continuous fermentation. A comparative study. Batch operations process specific amounts for consistent results. Continuous machines allow ongoing fermentation. Batch ensures uniformity with controlled feed and discharge times. Continuous may lead to uneven fermentation. CFM offers better control over variables like spread and time. Batch requires precise timing for consistency. Continuous can adjust to climatic conditions. Risk of channeling in continuous operations. Batch preferred for smaller factories, CFM for larger. Both systems need careful calibration. The impact of drum fermentation on tea quality and aeration. Drum fermentation provides better aeration than floor methods. Rotation ensures even air exposure for all tea particles. Leaf rubbing aids in juice coating results in blacker, brisker teas. Dynamic process ensures constant oxidation. Aeration critical to prevent flat flavors. Improves bulk density of the finished tea, ideal for South Indian CTC teas. Enhances flavor compounds development, prevents off flavors from poor oxidation. The role of ultraviolet radiation in enhancing fermentation. UV aids in accelerating fermentation. Kills external bacteria and triggers enzyme activity. Leads to faster biochemical reactions. Results in brighter infusions. UV chambers used for passing fermented dhool. Cannot be installed inside drums, but work well in continuous machines. Improves control over fermentation. Prevents microbial contamination. Ensures external bacteria do not taint tea. Emerging trend in modern fermentation practices. Best practices for factory hygiene in tea manufacturing. Hygiene is critical for high quality tea production. Bacteria can taint flavor and aroma. Cleaning of machinery and floors is essential. Machines must be cleaned with detergents and water. Accumulation of dust and debris should be avoided. The factory should be well lit for cleanliness. Impure water in humidifiers causes contamination. Regular sterilization with hot water or steam is necessary. Bacteria can survive initial stages of manufacture. Proper hygiene prevents contamination, preventing bacterial contamination. During fermentation, bacteria cause flavor taint and defects. Fermented juice left on machines harbors bacteria. Impure water in humidifiers leads to contamination. Cleaning fermenting drums after each batch is critical. Microbial growth can result in dark leaf and off flavors. Hot water or steam cleaning can sterilize equipment. Fluff and debris should be removed regularly. External bacteria disrupt fermentation. Detergent cleaning, followed by water rinsing, is effective. Prevents bacterial buildup and maintains tea quality. Innovations in tea fermentation, from UV chambers to better airflow systems. UV radiation enhances fermentation and bacterial control. Continuous fermentation machines, CFM, offer precise control. Improved airflow systems ensure better oxygen levels. Co-current airflow systems prevent spent air recycling. New drum designs allow better granulation and density. Innovations aim to reduce bacterial contamination. Modern machines control temperature and moisture better. Spiral flights in drums improve oxygen exposure. Technological advancements lead to better tea quality. Continuous improvements optimize fermentation processes.